All right, class, we're going to shift gears and talk about one last way to display data, and this is the coveted box and whisker plot. Okay, box and whisker plot is a graphical method to display data. Okay, it's yet another way to display data, and it really displays how spread out your data is. Okay, so a couple things that we want to talk about right now. So let's take a look at the box and whisker plot right now, right here. Notice how this number is the lower extreme. Sometimes we call this the minimum, right? The minimum value. The lower quartile is basically the median of your first half of data. It's the median of your first half of data. So it's kind of like your 25% mark. Your median is your 50% mark. Your upper quartile is kind of like the quarter of it's the halfway point of the second half. So the halfway point of the second half is pretty much like the 75% mark of data. And then your upper extreme is kind of like the maximum. Okay, so notice a couple things though. First, 25% of your data is from your lower extreme to your lower quartile. And did we notice, class, that this whisker, we call it a whisker, but this left whisker is much wider than this whisker over here. Okay. We also know that this box is effectively the amount of data from the 25% mark to the 75% mark. So this box really has 50% of your data, right? So like this is 25% of your data. This is 50% of your data, like the first quarter to the third quarter. And then from here is your last remaining 25%, which is the third quarter to the 100 mark. And what we're trying to do with the box and whisker plot, class, is we're trying to show how spread out your data is. So we could say that this is pretty wide, and that means there's a decent amount of variance, right? The word variance just means how variable, how much change occurs with your data. And you can see that this variance is decently wide. This box seems kind of normal. It seems like a decent amount of width. And then 25% of your data is within this small whisker as well. And the perfect example I would say for this is, or are grades, right? If this was grades for Mr. Quo, grades in Mr. Quo's class, you would say 25% of the class got this grade, which is very good. 50% of the class got a score of 50 to all the way to 90, which is good, but I kind of wish that it was not as near 50, because we all know that in the world of grades, 50% is an F. So I kind of wish the box was only like maybe from 70 to 90, right? And then here it's like saying 25% of his class or my class got 17 to 50. And that's not really a good thing to see, because that means 1/4 of the class got a score of 17 to 50. And that's bad, in my opinion. Okay. So let's formally define these one more time on our group. The lower extreme is what we call the minimum, and it is the lowest value. The lower quartile is the median of the first half of data. So the median of the first half of data is basically the first quartile, right? Quartile just meaning the first fourth. Quart means fourth. Upper quartile is the median of the second half of data. Which is kind of like the third quartile. right? The third quarter. The upper extreme is the maximum value. It's the number one score, the highest value. And then, this is something we haven't talked about, but the interquartile range. So we know that range, class, is a difference of the highest and lowest, but the interquartile range is going to be your upper quartile, whatever your score of the upper quartile is, minus the lower quartile. So it's your upper quartile, whatever your value is for the upper quartile, minus the lower quartile. And essentially, class, what this is it's the width of your box. It's the width of the box. Because the width of the box is going to be, you can see the outer edge of the box, class, is basically this number right here minus this number. That's your width. And this is basically the interquartile range, IQR. And then we then have something that we call outlier, which is any data points that lie outside extreme values that lie outside the range. Just write that. Okay. At this time, if you want to take a pause and just write down all these vocab words, I would definitely recommend that because I know I just gave you a lot of material. So maybe you want to take a pause break right here. All right, let's go. So it says, what percent of the data is higher than the lower quartile? Well, since the lower quartile is at the 25% mark, class, do we realize that there still is 75% of the data left, right? Let's say the data starts from here. You go all the way to the lower quartile. Well, that's only 25% of the data. So what percent of the data is higher than the lower quartile? 75% is still higher. The lowest 75% of data is less than which statistical measure? The lowest 75% of data is less than what we call the upper quartile. The upper quartile is basically the third quarter of your data, where 75% of your data is lower than that. What percent of the data is represented by the entire box? Well, we just said right here, the box is worth 50% of your data, right? It's worth 50% of your data. And is there an outlier for the data? In this case, let's just keep it simple and say no. There is a little bit more detail that I could add, but just for now, let's go ahead and say no. All right, so let's practice one way to display data. Now, we are going to display this data using the interquartile range and the box and whisker plot concepts, and just make sure that the numbers are always ordered from least to greatest. Okay, so this definitely requires practice, class. I know I just introduced these words to you, but you always want to make on the side, you want to write down everything. So I'm going to write min, LQ, median, UQ, and then max. Okay, you need to know all of these data points. Okay, so let's first calculate this. What is the minimum? Well, the minimum here is 60. What is the lower quartile? Well, the lower quartile is the first, it's the median of the first half. So let's count how many numbers we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So notice we have 15 numbers. So the special number is the eighth number. 1, 2, 3, 4, 5, 6, 7, 8. So The eighth number is directly in the middle, so that's not part of the first half or the second half. So make sure you don't include it. Okay, notice there's 15 numbers. I took the eighth number out, so there's 7 numbers over here. There's 7 numbers over here. Okay, so now I can find the median of the first half because that's my lower quartile, and the median of the second half is also going to be my upper quartile. Okay, so now that I have my first half, I am now going to calculate the median, which is out of 7, it's the fourth number. 1, 2, 3, 4. So 70 is going to be my lower quartile. The fourth number here is 1, 2, 3, 85, and that's the upper quartile. My median is actually 80, which I calculated already. Why did I write 7Q? I was supposed to write 7D. It's hilarious. And then my maximum is 90. Okay, so I'm going to repeat what I just did. The first thing you always want to do is you want to identify how many total numbers you have. So I calculated that I had 15 numbers. The median is always going to be the number directly in the middle. And you don't want to include this number in your first half or your second half of data because it's not part of either half. It's directly in the middle. Once I've separated the data into 2 halves, I then calculated the median one more time, and that gave me the lower quartile. Remember, class, the lower quartile is the median of the first half of data. The upper quartile is the median of the second half of data, which was 85. Okay, so now I have everything I need. Obviously, the maximum is the highest score. So I just have to create a line. And you have to realize what kind of intervals you should use. I'm going to go ahead and start with 55. I know that's a random start, but it's because I want to move in intervals of 5. Maybe if I want, I can add one more, 100. Okay, you don't have to start from 0. You always want to start from a reasonable number. Okay, and then you start plotting these points, right? Just like what we've seen here, right? You start plotting the points for the box and whisker plot. So we know that our minimum is 60. We know the lower quartile is 70. We know the median is 80. Upper quartile is 85. And the maximum is 90. And then I'm going to connect like this. And just like that, class, I have created the box and whisker plot. Okay, so let's label min, lower quartile, median, upper quartile, maximum. Okay, so a couple things I want to talk about right now. My question to you, class, is why is this portion longer than that portion? Right? Why do you think this left whisker is longer than this right whisker? The reality is it's because the data is more spread out on the left. The data is not as spread out on the right. Look at the scores. 85, 85, 85, 85, 85, 85. So, you would say a whisker that is not as wide means that the data is not as spread out. Right? And that could be a good thing and that could be a bad thing. We don't necessarily want data to be spread out. Okay? Take a look at this And always pause whenever you need. Let me know when you have